Hello, I'm going to start the second part of chapter 11.1, where we're going to actually complete the square. So what you learned in 11.1 up to this point is that you learned the square root property. So if something squared equals a constant, then that something is plus or minus square root of k. So but you see, for you to use the square root property, you need something squared, right? So what we're going to do is we're going to learn how to create something squared. So here, in this problem, there's a blank here, and I need this blank to be something that makes this a perfect square trinomial. Now let me work down here for a second and look at this old, if I had this back in chapter 6 and I said to you, hey, I want you to factor this. You know, you would have said, oh, it's a trinomial, start with x squared, so we do x and we do x and we have a product of 9. I want to show this stuff because it all ties back together. And then you have a deep understanding of it, hopefully. And my sum is -6. And I use a -3 and a -3, you see? And then you would have said, oh, okay, or I could write that as a something squared, you see, x, because it's a binomial squared. And a binomial squared turns into a perfect square trinomial. So, I need to be able to create this now, okay? I need to at this point. So you've learned a lot of math, and now you're going to manipulate things until you can create pieces that you need so that you can solve the problem. So I need something squared equals a constant eventually. So right now I'm just supposed to find a proper constant to the binomial so that the resulting trinomial is a perfect square. This is a perfect square here, you see? This here. So you're going to take a half b, and this is, do you see how that coefficient of the x term or the middle term, you see how we remember how we called this one is an a, and this here is a b, and this constant was called a c when we had, this was the standard form of a quadratic equation, remember? And the coefficient of the x squared term was called an a, and the coefficient of the x term was called a b. And what we're going to do now is we're going to take that half b quantity and square it. And what's on the inside here, so in this case, you're not going to keep rewriting the equation down once it's an equation, it's not even an equation yet. You're just simply going to say, what is this? A half. What is b in this case? It's a 6. And when you do this, don't worry about sign because we're just going to use that existing sign in our square. So a half times 6 quantity squared. What is the inside? So I want you to think about this. What is the inside? A half times 6 is 3, right? 3 squared is 9. This piece, what the inside is a 3, and the piece that comes out is a 9. The outside is a 9, and that's the piece we put right here. And then I'm going to make some room. See, because I really created a perfect square trinomial just now. We were only given part of it, and we made this number here so that it would factor into a perfect square. So, and then it says, then factor the trinomial. So that's step 2. Step 1 was finding that constant. So you found that constant, it's at 9. And then step 2 is factor the trinomial. Well, this trinomial factored is x. The sign from here goes in here. And the inside piece goes inside. You see how this was the inside piece? That piece goes inside. So I want you to remember this. The outside here goes outside, and the inside piece goes inside, and this is a square. Now, if you factor or FOIL this out, you go right back to this one. And this is a difficult concept for most students, so we're going to do several of them. I don't have very many of them that don't involve a fraction. So I'm going to clear the drawings. I'm going to scroll. Almost want to go straight into solving. Do you see this here? Solve the equation by completing the square. That's really what you're doing right now. First, you're completing the square, and then you're going to solve the actual equations doing that. So let's go ahead and work this one again, though. So I have x squared plus 17x plus blank. And then I'm actually going to go ahead and put equals, and then I'm going to put the factored trinomial here. You see? The factor of the trinomial, meaning creating a perfect square. This is that trinomial in factored form. So what we're going to do is we're going to take a half times b. You really have b divided by 2 technically, isn't that over 1? And square it. Now what is the inside? So we work our way down here and we have 17 halves. Do you see how it's just going to be 17 halves? And do you see how 17 halves, the inside is 17 halves? What would come out of that? What is 17 squared? I'm going to pause for a second. So this isn't the friendliest number really, but it's part of your homework, so I have to deal with it. 17 squared is 289. 2 squared is 4. So what happens is this piece goes here. This is really not going to help right now, actually, when we have something this complicated immediately. Oh. And what is that trinomial in factored form? The inside goes inside. So you have an x first, because this is an x squared. We have a plus, because this is a plus. And then the inside of this we put right here. And the outside, if you take the x plus 17 halves and you square it, you get x plus 17 half times x plus 17 half. And then you FOIL it. 17 half plus 17 half is 34 halves, which is 17, you see, because when you take that, and then you have a 289 over 4. And that's that. This is a perfect square trinomial. This is the perfect square that you would factor it into. Probably you shouldn't have had one that ugly right off the bat. You're gonna see quite a few with fractions. It'll be okay, I promise. So let's grab another one. And now we're actually gonna solve though. So for solving, let me use this. There's one I had marked because this will cover everything. So we're gonna write down the steps here and then we'll do a few more to clarify. I almost want one that isn't gonna have fractions. Hang on a minute. Maybe I should have worked them first so I would avoid. Let's do this one first, actually, because I wanted one that was a little less confusing with the little numbers pieces. Okay. Solve the equation by completing the square. So the step 1 is you need x squared plus bx equals c. And what I mean by that is you need the constant by itself on the right, and in this case already there, but the coefficient of the x squared term has to be a 1. Meaning you can't have a 2a squared, okay? So the first thing they'll say is get rid of that 2. How do you get rid of that 2? You divide by 2, and whatever you do to 1, you do to all. So you have a squared plus 4a equals -6. Then, so do you all see that? So the first thing you do is you get the constant over to the right, And you also make sure that you have a leading coefficient on that x squared that is just a 1. So we've done that here. Then the way I show it in class is I say, well, I need to create, do you see how this isn't something squared equals a constant? And you can't just move that over. So what we're going to do is we are going to create a perfect square trinomial. So what I'm going to do here is I'm going to rewrite this. I'm going to put a blank here. This is always plus. This could be a positive or negative, but this is always a plus, and I'll show you that again when we check it. And then on this left side, I have a -6. Now what I want you to remember is when I create a perfect square trinomial here, I'm going to end up adding something to the side that makes that happen. Whatever I do here, I have to do here. So putting that line right here will really help you. So first we needed this plus c is that, and then now complete the square. What we're going to do is we're going to create a perfect square trinomial. So I'm going to use a different color, a brown maybe, and I'm going to do that parentheses thing. I need a half b squared. In this case, what is b? A half b happens to be that coefficient of the a to the first x to the first term. So what is the inside? What is a half times 4, right? The inside is a 2. What would come out of this? 2 squared is a 4. So what you do is you put the outer one here. Whatever you do here, you have to do here. And then the inside, this is where you're now going to work. What your goal was. Your goal, something squared equals a constant. That was your goal. So now, right here, we're going to make something squared. That something squared, in this case, is this is an A, this is a plus, this 2, the inside goes inside, you see? The outside went outside, but whatever you do to one side of the equation, you have to do to the other. And then you have a -6 plus 4, which is a -2. Now you have something squared equals a constant. Then use square root property. So this is quite involved. So now I still have to do all that stuff we did at the beginning of 11.1, so I don't even know if I have a room now. Square root plus minus, right? So we have a plus 2 comes out, plus or minus, the square root of -2. Then isolate the a, and we'll take care of that. So a is, what do you do to isolate the a here? You subtract 2. We're not going to hang it at the end. We're going to say -2 plus or minus, and the square root of -2 is I square root of 2. And this would be your final answer. So this is a little bit difficult to teach. It's also difficult to learn. So these steps here in the brown, that's not, I don't want you to rewrite an equation every time you do that. I want you to go straight from, this is your perfect square trinomial, and this is the perfect square that goes with it, right? That in factored form. So that's what you practiced on the first couple of this. So let's do another one. It's difficult. This one is a difficult concept, so we'll have to do lots of practicing on this. It's completely normal. Let's do this one. Some of them are faster than others, so. X squared plus 7x. Okay, so here, look at this. Step 1, what do you need? You need, first, you need x squared plus bx equals c, meaning you've got to get that constant out of there. So you're going to add 1. Then you make sure that your coefficient of the x squared term is a simple 1, which in this case it is, so you don't do anything else. Now you're going to complete the square. Blank. blank. So this is going to be a plus no matter what. So now complete the square. How do you do that? You do that with that half b thing. A half times, b in this case is a 7 squared. What is a half times 7? 7 halves squared. Inside is 7 half, outside is 49 fourths. Outside goes here and there. So I like doing all the arrows because it keeps you organized. Then you say, well, outside is 49 fourths. Whatever I do to one side, I do to the other. Inside, meaning that something squared, inside is that x, that plus, and that 7 halves, because that's the inside, you see? And then the outside is still, here you have to do the work. So this can be a bit of a problem too for those of you who hate fractions. There's going to be lots of this going on. 49 fourths, 1 plus 49 fourths. You know, let's do this over here. This is basic math that trips people up. 1 is 4 over 4. 4 and 49 is 53, you see? So 1 plus 49 fourths is 53 fourths. Now you have to take, you've completed the square, so you have something squared equals a constant. Now you're going to use the square root property. So now you're going to take a radical and x plus 7 halves comes out. And then on the right side, you're going to have a plus or minus the square root of, and I'm going to go ahead and split it up. You see this? And then I run out of space. That is a problem a little bit, but I can't help it. I want to arrow over, sorry folks. So then I'm going to, I'd like to go ahead and do two things at once, but I'm going to go ahead and keep it very basic. Square root of 53 over, is the square root of 4 is a 2? Yes. So x equals negative 7 halves plus or minus square root of 53 over 2. If this had been a negative under the radical and you would have had an I with it, you need to keep them as two separate pieces. Since it does not have an I with it, you could write this as x is negative 7 plus or minus square root of 53 all over 2, and that would be your final answer. Or you could write it separately, x is negative 7 minus square root of 53 over 2, all over 2. Or x is minus a negative 7 plus square root of 53 all over 2. Okay, so not the easiest section, this one. We did that one. I'm going to do, which one do I want? This one here will do fine for both of those. Let's do 14 and 15, and then we'll call it good on this. So 14. Solve the equation by completing the square. And they're telling you it has real number solutions, so meaning it won't be an imaginary, it doesn't really matter. They shouldn't really tell you this. We'll figure it out as we go. Okay, so first thing you need is x squared plus bx equals c. So you have to remember this, you need standard form or this form constant on the right. So you have to first move stuff around. So you have a 9y squared minus 12y equals 1. Do you see how, because you had to move the 12y over, and then you had to move that 1, negative 1, add 1, add 1. Then you have to get rid of that coefficient on the x squared term, on the y squared term in this case. So you need to divide this by 9, whatever you do here, and you do here. This is kind of a pain because now you have fractions, you know, but such is life. So you get a y squared minus 12 over 9, you know, divide by 3, right? So this is basic math. You do want to simplify that first. And then you're going to say, okay, I'm going to go ahead and save a little space. I need to create a perfect square trinomial equals. And then that 1/9 is on the right. and there's a plus here, always plus, because if you got to think about this, if you have a binomial squared, the last term's always a plus when you FOIL it. So, and then I'm going to put the line here so I don't forget to add to this side. Whatever I do here, I have to do here. Okay, now we're going to do, so we took care of, we did this part. We have something and something is a constant, and I made myself my spacers. I need those spacers. Okay, so now we're going to say, well, and I'm not going to worry about sign. I'm going to say what's a half times b squared. The 4 and the 2 cancel, or you can say 1 times 4 is 4, 4 over 6 is 2 over 3. You see what I'm saying? So 4/6 is the same thing as 2/3. You want to keep it simple. So the inside when you simplify is a 2/3. 2/3 squared is 2 squared over 3 squared. So this is the outside piece. It goes here and there. And then we're going to complete what we completed the square. So we created a perfect square trinomial. Now we're going to put it into that form that we need. So here we have a y. Here we have a minus, you see? So you just bring that negative down. The inside goes inside. The outside went outside. This is taken care of because this trinomial is this. If you FOIL this out, you're going to go right back here because you're going to have y minus 2/3 times y minus 2/3. FOIL it out. Negative 2/3 times negative 2/3 gives you this as the last ones. Now, 1/9 plus 4/9 is not hard, okay? So this is just because you see fractions does not need to concern you. That's just 5/9. And then I do the square root plus minus, right? So if you show that, some of you like showing that. If you just use the square root property, you wouldn't really, you know. But then on the left side, you have the y minus 2/3 comes out. On the right side, you have a plus or minus square root of 5 over square root of 9 is a 3. Yes, square root of 9 is a 3. And then you simply isolate the y for the last step. So y is 2/3 plus or minus square root of 5 over 3. And again, these are real number solutions, meaning there's no I, so you don't have to keep it in separate pieces. I need one that has an I with it, so you'll see what I'm trying to talk about here. But you would simply say, oh, they have a common denominator. I can show it like this, and this is your final answer. Okay, I think it's getting better. Usually you need several of these, and then life is pretty okay. It just takes time. This is a difficult concept, and you really, really, really need this for your next class. This is one of the biggest deals I hear about that instructors struggle with their students that don't know how to complete a square. Okay, let's try this one. 9x squared. So in the book, they will actually get rid of that 9 first, but I always like to move my constant over first. So everybody's different, but you all agree that this is true, yes? And then you would say, okay, first you get rid of that 41. Now I need this coefficient to be a 1, so I have to divide by 9, divide by 9, divide by 9. So then you get x squared minus, what is 12/9, 4/3? You see how we had something very similar already. Simplify, divide by 3, divide by 3. And now this time we have to deal with, oops, I'm going to go ahead and leave myself a space here since I'm limited on space. You might do an extra line. I'm going to say I'm going to have a plus and something. And then here I have a negative 41/9 plus something. Now I'm going to complete the square. I have a half times 4/3. You see how this is kind of repetitive. Half b squared. A half of b is 4/6 is 2/3. And then it's 4/9 again. So this goes here and there, because whatever you do on one side, you have to do to the other to keep it equal. But you've created a perfect square trinomial that factors into x minus from there, 2/3 quantity squared equals negative 41 ninths plus 4 ninths is negative 37 ninths. And then we have to use the square root property. And again, I didn't show this every time because we really don't need to show this every time. What we need to show is that if something squared equals a constant, then that something is plus or minus the square root of that. And then you go from there. And then I'm out of room. So x equals, see how I'm going to go ahead and move that 2/3 over now? And then I'm gonna say it's plus or minus square root of -1 square root of 37. Square root of 9 is just 3. And I have to write up here, sorry folks, this is very messy. So from here I have x equals, do you see how this is going to have an I with it? Whenever you have an I with it, you got to have a real part and an imaginary part. So you cannot put them together over the common 3. Do you understand? Like with the denominator, we're going to have to leave this like this, square root of 37 over 3i. Because when you have a complex number, it has to be a plus bi, meaning a real part and an imaginary part. They have to be separate. If it doesn't have an I, then you can put it all over 3. Okay, I think that's enough for 11.1. It's a bit hefty, so hang in there. The rest of it is a breeze, okay? So just this one, you need to do a lot of practicing and then ask questions in class. Yes, thank you.